Hello, my name is Imed Hammouda from Chalmers and University of Gothenburg. Welcome to the Advanced Software Architecture course. The topic of this lecture is Analysis of Software Architecture. The agenda is as follows. First, we will define what architecture evaluation is. We will then briefly introduce a number of evaluation approaches and discuss the benefits and limits of architecture evaluation. Next, we will discuss in detail a concrete scenario-based evaluation method known as Architecture Trade-off Analysis Method, ATAM. Finally, we will go through an example evaluation exercise of a concrete software system known as SOLA. Before we proceed with the discussion, it's important to note that the terms analysis, assessment, evaluation, and validation will be used in this lecture interchangeably. In the first part of the lecture, we have defined and characterized software architecture evaluation. In the second part, we introduce Architecture Trade-off Analysis Method, ATAM. SOLA architecture evaluation will be discussed in the third part of this lecture. What is ATAM? ATAM stands for Architecture Trade-off Analysis Method. It is a scenario-based evaluation method that focuses on a system's quality goals such as modifiability, availability, and security. There are a few assumptions related to applying ATAM. When the method is applied, evaluators need not be familiar with the system architecture nor its business goals. The second assumption is that the system is not necessarily implemented. Thirdly, the method assumes that a large team of project stakeholders is involved in the evaluation process. Let's review what a quality attribute scenario is. A quality attribute scenario is a quality attribute specific requirement that consists of 6 parts. Source of stimulus is the entity that generated the stimulus, for example, a human user or a computer system. Stimulus is the condition that needs to be considered when it arrives at a system. Environment is the particular conditions in which the stimulus occurs. Artifact is the system or the pieces of it that are stimulated. Response is the activity undertaken after the arrival of the stimulus. Finally, response measure is the measure by which the response will be evaluated when it occurs so that the requirement can be tested. Let's consider an example quality attribute scenario for security of a web-based system. An unknown human user could be a source of a stimulus, which in this case could be an attempt to delete data. In this example, the environment is the system running in normal mode, and the artifact touched is the system data stored, for example, in a database. The example response could be to lock the computer, and the response measure could be the amount and kind of data loss. But how to elicit and identify quality attribute scenarios? ATAM uses a technique known as utility tree in order to identify quality attribute scenarios for the software system under evaluation. A utility tree is a hierarchic model of the driving architectural requirements of the system. First, relevant system quality attributes are identified. Then specific quality requirements for each quality attribute are listed. For each quality requirement, a number of scenarios for that requirement are identified and documented together with 2 values, their business value and architectural impact value, which could be high, medium, or low. Those 2 factors help stakeholders in prioritizing the quality attribute requirements and thus scenarios. Let's now see the kind of activities involved in ATAM. Architecture evaluation in ATAM is organized into 4 activities. First, the scenarios are collected and system requirements are made explicit. Next, architectural views are considered in order to go through the identified scenarios. The architecture is then evaluated against each scenario. Finally, the evaluation results are formulated and presented. The evaluation process is depicted in the following conceptual flow. There are two input tracks to the evaluation. In the first input track, business goals are translated into system quality attributes and expressed in terms of quality attribute scenarios. In the second input track, architectural decisions are identified reflecting the architectural plans and approaches taken. Analysis is performed by mapping the architectural decisions to quality requirements expressed in the scenarios. The output of the analysis is expressed in terms of 4 items: trade-offs, sensitivity points, non-risks, and risks. Risks are then grouped into risk themes. The risk themes are considered in a next iteration of evaluation. The architecture is fine-tuned after each evaluation iteration. The evaluation cycles continue till all risk themes have been addressed. ATAM output is organized into 5 artifacts. Sensitivity points are parameters of the architecture to which some quality attribute is highly related. Trade-off points are parameters of the architecture that affect multiple quality attributes in opposite directions. Risks are potentially important architectural decisions that may cause problems. Non-risks are good decisions, frequently relying on implicit assumptions. Risk themes are groupings of risks identified by some common factors. How ATAM is planned and implemented in practice and who is involved. As we said earlier, ATAM typically involves a large number of participants. The first participant is the evaluation client, who is the person, group, or agency that has commissioned the evaluation of a software architecture. The second group is the evaluation team, which is a group external to the project whose architecture is being evaluated. The group may consist of roles such as team leader, evaluation leader, and scribe. The third group is project decision makers. These people are empowered to speak for the development project or have the authority to mandate changes to it. Finally comes architecture stakeholders, who have a vested interest in the architecture performing as advertised. In phase 0 of ATAM, partnership and preparation, the evaluation team leadership and key project decision makers informally meet to work out the details of the evaluation. For instance, the project representatives brief the evaluators about the project so that the team can be supplemented by people who possess the appropriate expertise. Further, the two groups agree on logistics such as the time and place of meetings and who should be involved. During phase 1, the evaluation team meets with the project decision makers, usually for about a day or two, to begin information gathering and analysis. Business drivers are presented, the architectural approaches are identified and analyzed against the quality scenarios. The phase is expressed in terms of 6 steps, as you can see on the slide. For phase 2, the architectural stakeholders join the proceedings and analysis continues, typically for 2 days. The new stakeholders bring in new scenarios that might have been missed in phase 1. The evaluation results are then presented in terms of architectural approaches, documentation, scenarios and their prioritization, utility tree, risks discovered, non-risks documented, sensitivity points, and trade-off points found. The phase is expressed in terms of 3 steps, as you can see on the slide. Phase 3 is follow-up, in which the evaluation team produces and delivers a written final report. The essence of this phase, however, is team self-examination and improvement. During a post-mortem meeting, the team discusses what went well and what didn't. The following figure shows a form for capturing the analysis of an architectural approach for an availability-related scenario. As shown, based on the results of this step, the evaluation team can identify and record a set of sensitivity points and trade-off points, risks and non-risks. All sensitivity points and trade-off points are candidate risks. By the end of the ATAM exercise, all of them should be categorized as either one or the other. The risks, non-risks, sensitivity points, and trade-off points are gathered in separate lists. The numbers R8, T3, S4, and 12, and so forth in the figure are simply pointers into these lists. To wrap up, in this part 2, we have presented a concrete scenario-based architecture evaluation method known as ATAM. It is important to note that ATAM as such is not used to evaluate neither requirements nor source code. Further, ATAM is not used as part of system testing. It is an effective evaluation instrument that suffers from own limitations. This was lecture analysis of software architecture part 2. Thank you for watching.